Okay, this is 6.4D, video number 4 of the lesson that never ends. And I'm not 100% sure if I finished these two. If I didn't, please tell me. The answer to this one is just negative cosine of x. And this one is cosine of x. I don't know if I finished them or not. I'm not sure. Let me know if I didn't, and I'll go back and redo them. I can't remember where Nick's mom came in and got me and stopped me. Let g of x equals the integral from 1 to the x of the square root of 1 plus t to the third of dt. And it asks what is g prime of x. It says, why is this example different from the previous examples? Well, because we don't know what the antiderivative of the square root of 1 plus t to the third is. So we don't know the antiderivative. Okay, we're just going to pretend. Suppose the antiderivative of the square root of 1 plus t to the third is h of t. So that means that the derivative of that would be the square root of 1 plus t to the third. It says, so using h of t, evaluate the right side of the equation. Well, g of x equals, it would be h of t, the antiderivative of the square root of 1 plus t cubed, from 1 to x, and that'll be h of x minus h of 1. Whoops. Now it asks me to take the derivative of that. Well, h of x would be the square root of 1 plus x to the third minus the derivative of a constant would be 0. So it's just the square root of 1 plus x to the third. What you should have gotten from all this is if we take the derivative of an integral, we'll sum it up for you really fast. The whole main part of this is you just take that and stick it in there. And that's the answer. The derivative and the integral cancel out. And you just take these and stick them in. Now you do have to account for your chain rule here in just a minute. Since the integral portion, basically this is the fundamental theorem of calculus part 1. Simple. Essentially you stick this in there and these cancel. This is in your own words. Describe what happens when we take a derivative of a definite integral from a constant x. The derivative and the integral cancel out and you stick the x in. So if g of x equals the integral from negative 2 to x of wt dt, then g prime of x would just be w of x. Yay, easy. Example 16, I'm going to do the same thing here. The derivative and the integral cancel out. I stick the x in everywhere there's a t, so it would be 5x squared minus 6x plus 1. Now it's going to get a little harder. It says, how is the next example different? And now I'm kind of trying to decide whether or not I want to show you why the chain rule is what it is, or if I'm just going to, I feel like you're going to get confused in the working of the problem. I'll be happy to show you individually if you want to know why you do what you do, but essentially you just stick the 3x squared in. The derivative and the integral cancel out. You stick the 3x squared in everywhere there's a t, so you do 5 times 3x squared minus 6 times 3x squared plus 1, and you have to multiply that entire thing times the derivative of 3x squared, because you're taking the derivative of the integral. Well, and that's the chain rule. Because you're taking the derivative, you have to multiply by the derivative of the inside, and the derivative of the inside is the 3x squared. And for sake of time on the video, I'm not actually going to go through and show that, but that's all you do. And then you would subtract the bottom away. But here's the thing, when you subtract the bottom away, when you times by the derivative of 2, it's 0. So that second part cancels out. Here's another one. Now notice this one has a function on the top and on the bottom. So this is what you do if there's a function on the top and on the bottom. The derivative, we're trying to find the derivative of the integral. So the derivative and the integral cancel out. you fill in the 3x squared where the t is, okay, times by the derivative of 3x squared, minus, you fill in the bottom, the square root of 1 plus 5x to the third, times by the derivative of 5x. And that's all. That's it right there. That's all you do. So that was the, notice any patterns? Oh, I went ahead and worked it. I went ahead and gave you the pattern. This is the fundamental theorem of calculus extended. Like, I really should have worked it and showed you how you got what you got. But for sake of time, I'm not going to do that. If you want me to do it in class tomorrow, let me know and I will. Or when you finish, just let me know and I'll do it for everybody together. You just take, this is the theorem, derivative of integral, it cancels out. You take the u of x, you fill it in where the t is, right here, and you multiply by the derivative. Minus, fill the v in, multiply by the derivative. So here's another one. We're just going to take the 3x, stick it in where the t is, so it'd be f of 3x multiplied by the derivative of 3x minus f of x squared multiplied by the derivative of x. Okay. Alright, so example 20. This is where we get into the AP free response questions. Putting it all together, it says, suppose the function below is the graph of f of t and g of x in the integral from -1 of f of t dt. Complete the table. And I'm not going to do every single one of these like this. I'm not going to write them all out, but here's the first one. It's from -1 to -3 of f of t dt. Well, from -1 to -3, the first thing I notice is these are switched, so whatever my answer is, it's going to have a different sign. So from -1, let me highlight this, -1 to -3. Wow, let me highlight it better than that. That's a little ridiculous. -1 to -3. Now what's going to happen to those two areas? The one on the top cancels with the one on the bottom. I'm actually going to get 0. And then for g of -2, I would do the integral from -1 to -2. Again, notice that the limits of integration, the -1 and -2, are switched. The one on the top is smaller than the one on the bottom. So I'm going to negate whatever my area is. So from -1 to -2, that's a triangle. 1/2 base times height. So it'll be 1, and it's below the x-axis, so it's negative, but I'm negating it, so it's going to be a positive 1. -1 would be from -1 to -1. That's going to be 0 because my limits are the same. Continuing to find my areas from, if I erase this, from -1 to 0 is my next one. G of 0 would be from -1 to 0. That would be, again, a -1. It's below the x-axis, 1/2 base times height. Now I'm going from -1 to 1. So this is -1. That looks like a -1/2. So it would be -1.5. And then just continuing across to 2. I'm adding in another -1.5 because that's -1, that's -0.5, so it looks like -3. And then I'm adding in to -3, I'm adding in 2.5 more negative, so it would be -5.5. It said, what are the intervals on which g is increasing or decreasing? Justify each response. Well, how do you determine if something is increasing or decreasing? It's increasing where the derivative, g prime of x, is greater than 0, and it's decreasing where g prime of x is less than 0. That's the justification. I always write the justification first because I can get points for the justification even if I don't get the answer right. So I need to figure out what g prime of x is. Well, g of x from above is defined as the integral from -1 to x of f of t dt. Well, g prime of x is the derivative of that. Those cancel. So g prime of x is f of x. So this graph is the graph of the derivative g prime of x. So essentially they gave you the graph of the derivative. So the question is, where is the derivative less than 0 or below, increasing. Hold on, we'll do above first. Where is it increasing? Where is it greater than 0? Where is it above the x-axis? Where is f above the x-axis? Well, it's above the x-axis from -3 to -2, and that's it. Where is it below the x-axis? Well, it's below the x-axis from -2 to 0 and from 0 to 3. Okay, because I'm looking for where f of x is below, and we'll do a bunch of these because these are a little confusing at first. Okay, it says, what are the intervals on which g is concave up or concave down? Well, remember, concave up and concave down come from the second derivative. It's where g prime of x is greater than 0 and g prime of x is less than 0. So in relation to f, if g prime of x is f of x, then g double prime of x would be f prime of x. So I want to know where the derivative graph, because if this is g prime, I want to take the second derivative of this, so I'm looking at the slope. So where is it? Let's do concave up in green. Concave up is where g prime of x is increasing, and concave down is where g prime of x is decreasing. Oh, I was going to do them in different colors. Oh well. So I'll do increasing. It's increasing here, and then it's decreasing here and here. Decreasing. Okay, so it's increasing, looks like from -1 to 0, and it's decreasing everywhere else, so from -3 to -1 and from 0 to 3. And there, my justifications are already there. For what value of x does g have a relative maximum? G has a max where g prime of x changes from positive to negative. And remember, we're looking at the graph of g, so where does it change from positive to negative? At x equals -2. For what value of x does g have an inflection point? Well, inflection points come from where g prime of x, where g double prime of x changes signs, but we're looking at the graph of g prime, it's where g prime changes from increasing to decreasing, or vice versa. So, in other words, it's the maxes and mins of the graph of g of the derivative. So, it looks like at -1 and at 0. Remember, inflection points are just maxes and mins. X equals -1, x equals 0. Okay, so now I've got to graph the graph of g. So I'm going to do a little sine graph based on what I have above, and it goes from -3, -2, -1, 0, 1, 2, 3. I went too far. I don't need all that. 3. So if we look up here, and I can actually plot my points because I have this handy-dandy table, so I'm going to plot these points right fast. I've got at -3 it's 0, at -2 it's 1, -1 it's 0, 0 it's -1, 1 it's -1.5, 2 it's -3, and 3 is -5.5. So 1, 2, 3, 4, 5.5. 1, 2, 3, 4. 1, 2, 3, 4, 5.5. I cannot count. And then if we look at just going back to the top, g prime of x was positive between -3 and 2, and it was negative the rest of the way. And that's just from this graph up here, above and below the x-axis, way up there. I'm going to look at the one on my paper and then just so I don't have to keep scrolling back up. Just look at the one on your paper. G double prime of x, and this is G prime of x, and I'm going to do G double prime of x below it, just so we can have, it's negative, it's decreasing, decreasing, then it's increasing from -1 to 0, and then it's decreasing the rest of the time. So from -3 to 2, it's increasing, concave down. From -2 to 1, decreasing, concave down. At -1, it's decreasing, concave up. At 0, it's decreasing, from 0 to 1, it's decreasing, concave down, and it's concave down, decreasing the rest of the way. So it should look like that. And we are finally done with all new information before Christmas. Yay! The end.